Good morning, everyone. This is the class 10th ICSE Physics, Chapter 3, a quick overview of the part of machines which we call as pulleys. This is a basic revision of the types of pulleys. The first pulley that you should know is single fixed pulley. What is a single fixed pulley? What's a pulley? It's a wheel with a groove over which the rope can pass, and if you hang it from a fixed ceiling, then it is called a single fixed pulley, and you pass the string over it. This string always, in all cases, is inextensible. That means the length of the string will not change, and it is massless, always, in all the pulley cases, right? This pulley can be massless, it can have mass, but in both the cases, whether this has mass or this does not have mass, does not make a difference, because who is bearing the load of this? Who is bearing its weight? That is the ceiling, not us. So for every fixed pulley, whether it is massless or it has mass, does not matter to us. In any kind of pulleys, the fixed pulley's mass does not matter, right? Now, you have a load here and you apply an effort here. Effort means you are pulling it down with your hand. You're pulling it down. This is load. This is the load which you have to pick it up, right? The load has weight mg. Because earth pulls everybody down, so load has weight mg. Due to this part of the string has tension. कि oh my god, मेरी shape change हो रही है, ये मेरे को नीचे खींच रहे हैं, right? My shape may change. So this part of the string has tension, so it calls all the molecules and tells them somebody is trying to pull us down. So we should remember that we are inextensible. We will not change our length. So let's unite together against mg. That is called tension in the string. That is the electrical force in the string. The molecules are talking to each other. French, Romans, countrymen, let's unite against this who's trying to pull us down. That is called tension. Similarly, this part of the string, it's the same string. This part of the string says the hand is pulling us down. So the hand wants the length of the string to be changed. All the molecules of this string also says, French, Romans, countrymen, let's unite against this effort which is trying to pull us down. We will not. At least we'll try to oppose it. So that is tension. If there is one string, every strand will have tension and the tension will be equal if there is the same string. Done? Two important things about this pulley is, one is called mechanical advantage, the other is called velocity ratio. So in this video I'll tell you how to learn the values. For ideal single fixed pulley, mechanical advantage is 1 and velocity ratio is also 1. What is efficiency? It's mechanical advantage over velocity ratio. So that is 1 over 1. That is 1. Percentage efficiency is, you multiply efficiency with 100. These four things you should remember about this fixed pulley. Mechanical advantage 1, velocity ratio 1, efficiency 1, or percentage efficiency 100%. It is not a force multiplier. It is not a speed multiplier. Then why are we using it? Remember, it is used only to change the direction of effort to a convenient direction. In all the pulleys, if it is a non-ideal case, please remember, if it is a non-ideal case, even then you have a best friend called velocity ratio. Velocity ratio will never change. If I am saying for single fixed pulley, ideally velocity ratio is 1. For every single fixed pulley, velocity ratio will be 1. It will never change. It's your best friend. Mechanical advantage for non-ideal single fixed pulley reduces from 1, it will be lesser than 1. Therefore, efficiency will always be, for non-ideal cases, it can be less than 1. Efficiency can be less than 100. Everything will change, decrease, except for velocity ratio. Now, what do you mean by non-ideal cases? Because of the dissipative forces acting, there can be friction. In this, there can be the viscous drag, any other air resistance, any of them. But here also, the weight of the pulley will not change anything because the weight is being borne by the fixed pulley. So these basic things you should know about the single fixed pulley. The second kind of pulley which you have to study is single movable pulley. It's a single movable pulley. Now what's a single movable pulley? You have a rigid support and you have a pulley, but it is not hanging from the rigid support, right? The ceiling is not bearing the weight of this pulley. So who's bearing it? It will fall down because it's nowhere fixed. So what you do is you have a string. You have a string tied to a hook here, comes down. There it goes, and you apply the effort upwards. And where is the load which you have to pick? The basic need is you pick the load. So load is attached to this center. This is the load. Now, who is bearing the load of the pulley? This is the useful load. But if the pulley is not massless, who is bearing the load? It is the hand which is pulling it up. Somebody which is giving you the effort. Remember, single fixed pulleys or any fixed pulley, rope goes over it. So, we are not bearing the weight of this. But movable pulley, rope goes below it. So, we are bearing the load. So, here if the single movable pulley has load, things will change. Things will change, right? Now, what do you want to remember? Load is downwards. So this part of the string says again, it has an emergency meeting of all the molecules. Somebody is pulling us down. But we should unite. We should not try. We should at least try so that we are not extended. So you have tension here. And you have a tension here also. Right? So what is the mechanical advantage? I'll explain tensions in the next video. If anyone is interested, you can watch the next video. Here, but what you should remember, for single movable pulley, mechanical advantage is 2 for ideal case. Velocity ratio is 2. Therefore, efficiency is mechanical advantage over velocity ratio 2 by 2. That is again 1. Efficiency is 1. And percentage efficiency is again 100. How do you get percentage efficiency? It's mechanical advantage over velocity ratio into 100. So, percentage efficiency is 100 for ideal case. One more thing you should remember. If effort moves a distance x in movable, single movable, if effort moves a distance x, the load will move a distance x by 2. This is something important for single movable. Distance moved by effort is x, then distance moved by load is x by 2. Only then you get this velocity ratio. Again, who's your best friend? Who will not change? Even if this pulley has load, even if you have friction, even if you have anything else, your best friend is velocity ratio. It will always remain 2, even if it is a non-ideal case. Mechanical advantage will be 2. But for non-ideal case, mechanical advantage will be less than 2. Efficiency will be less than 1. And percentage efficiency will again be less than 100. But something in pulleys which does not change, whether it is ideal or non-ideal, is velocity ratio. Single fixed, velocity ratio 1. Single movable, velocity ratio 2. Whether it is ideal case or non-ideal case. Right? Single movable, you remember this. Distance moved by effort is x. Then distance moved by load is x by 2. The third kind of pulley that you have is one movable and one fixed pulley. Now how do you make it? You had a movable pulley, you tied a rope to it and you attached the load to it. Right? We did it in the previous case. Now this effort is upwards, which is very, very inconvenient to pull something up. So just to be convenient, we have another pulley, and what we do is, you can make it a little this side, we have another pulley which is fixed, and the same rope or the string which you have, massless, inextensible, you pass it over like this, and you apply the effort here. Now this I am calling the movable pulley, and this is the fixed pulley. One movable, one fixed. Where will be the tension? Who will have tension? This part of the string, this part of the string, this part of the string. They may all have tensions. But the load and these tensions are together. What is the formula when you have one fixed and one movable? Why are you using the fixed part? To change the direction of effort to a convenient direction. In this case again, mechanical advantage is 2 raised to power n. That is, n is what? Number of movable pulleys. Please remember. So how many movable pulleys you have? 1. So it's again 2. Mechanical advantage is 2 in this case again. Velocity ratio is again 2 raised to power n. N is number of movable pulleys. Efficiency will be mechanical advantage over velocity ratio. 2 by 2, 1. Percentage efficiency will be mechanical advantage over velocity ratio into 100. That's 100%. Here also, distance moved by effort is x. Distance moved by load is x by 2. Please remember all these things. This is for ideal case. This is for ideal case, means this is massless. Movable pulleys, mass matters. Weight matters. Fixed pulley, we don't bother whether it is anything, right? But if it is non-ideal case, who's your best friend? Whatever happens, ideal, non-ideal, pulley has weight, anything, velocity ratio will be 2 always. So remember, one movable, one fixed, velocity ratio again 2. But mechanical advantage will be less than this. Efficiency will be less. Everything decreases, nothing increases. Everything decreases except for the velocity ratio, right? Next case that you have is many movable and one fixed. It's just an extension of this case, right? How do you make it? You have a rigid ceiling, and you have a pulley, and you have a string around it, and you have the load. This is your movable pulley number 1. I call it movable pulley number 1. Now, we don't apply effort here. What we do is, we have another pulley here, which is fixed with this, and another string. This is now a separate string going up. This is movable pulley number 2, right? And then we have another pulley where this is attached. Now this is movable pulley number 3. Now the same will pass over, the same will string the same string, and now you have a fixed pulley. What will happen to this fixed pulley? Only one is fixed. This is your fixed pulley, right? Now this string, third string, will pass over the fixed, downward effort. How many strings? 1, 2, 3 strings you have used, right? How many pulleys? Total number of pulleys 4. But how many movable pulleys? That is 3. Again, the ideal case, mechanical advantage is 2 raised to power n. That is, n is number of movable pulleys. It's 2 raised to power 3. 2 to the 4. 4 to the 8. Velocity ratio is also 2 raised to power n. N is number of movable pulleys. So it's again 2 raised to power 3, 8. Efficiency is mechanical advantage over velocity ratio. That is 1. And percentage efficiency is mechanical advantage by velocity ratio into 100. So it will be 100%. This is for ideal case. But if it is non-ideal case, But if it is non-ideal, now you can always repeat with me. If it is non-ideal case, something will not change. Yes, it's the velocity ratio. Not changing in any condition. Best test friend. Right? What will decrease? What will increase? None of these. What will decrease? It will be less than 8. Efficiency will be less than 1. Efficiency percentage will be less than 100%. At least these things you should know. Right? At least these things you should know. The next we have is the block and tackle. Here you have a block of pulleys and you have tackle means a string. So it's one string that you call as tackle and many pulleys. When you had one movable, many movable, one fixed, there you had many strings also. This is different. This has only one string. Pulleys number will change. So there are two types. One block you call as fixed block and the other block you call as movable block. Now in fixed block, for example, you have two pulleys. So how do you make it? The first one should be wider and larger. Second one will be smaller. This is fixed pulley 1, fixed pulley 2. In the movable block, either you will have equal number of pulleys or one less than fixed. Movable part will have either what? Equal number as fixed or one less. So I make this as 1 and with it you hang the load. Getting it? Now where's the string which you call as tackle? Where is it? Here it is. Goes over it. Here you apply the effort. Goes over it. Comes down. मैंने पहले कहा movable के नीचे से fixed के ऊपर से. So it goes below the fixed, below the movable, above the fixed. Where next? All are covered now. So it comes here with a hook, you attach it. Are you getting it? How many parts of the string are here? 1, 2, 3. Every part will have tension T which is same. Why? Because the string is the same. One string, one tension. You don't take tension of this. Load is not attached to this. This is effort. How many are here? 1, 2, 3. Right? So, 1, 2, 3 tensions. Load is downwards. Mechanical advantage is N. What is N? It is the number of pulleys or it's the number of these 3 segments. So, here it is 3. Velocity ratio is again N. Total number of pulleys or the total number of these string segments. These 3, not this. This is the effort part here. Nothing to do in picking up the load. This is not doing anything. Efficiency is mechanical advantage of velocity ratio. 1% efficiency is 100%. Who is your best friend? If this movable one has weight, then still velocity ratio remains the same, but mechanical advantage will be less than 3, less than 1, less than 100%. Only if movable has mass. Fixed mass, we are not bothered. Right? Now, the other case can be, you have a fixed block, you have a movable block. First one, सबसे बड़ी पुली पहली, फिर छोटी बेटा, otherwise the string will not pass. इसमें पहले छोटी, बाद में बड़ी. F1, F2, 2 fixed pulleys, M1, M2, 2 movable pulleys. The movable will have either one less or it will have equal number of pulleys. 2 fixed, 2 movable. 2 fixed, 1 movable. Or 3 fixed, 2 movable. 4 fixed, 3 movable. Or 3 fixed, 3 movable. 4 fixed, 4 movable. Any case. Now where's the string going? Let's check the string. Above the fixed, below the movable. Above the fixed, below the movable. All 4 covered. Where will the string go? It will go and get attached here. Here's a string here. The hook. Getting it? See, if movable was 1 less, then the hook was with the movable. But if the number is equal, then the hook is with the fixed part. Here is the effort. I'm not making tensions very clearly here, but still remember, Here again, mechanical advantage is N. N is number of pulleys. 4 pulleys. And how many strings are, bearing the load? How many strings are bearing the load? Not this one. This is to bearing the effort here. So effort is equal to T है, वो अलग बात है. But how much is the load bearing? One is this, T, T, T and T. 4. That is the number of pulleys. So mechanical advantage is 4. Velocity ratio is again N, it is 4. Efficiency is 1. Percentage efficiency is 100% for ideal cases. Non-ideal cases, velocity ratio तो भाई बन गई आपकी best friend, वो तो change नहीं होगी. Everything else will decrease, not increase. Remember that. Get it? There is another case for block and tackle, which is different, in which you cannot say number of pulleys 4, so N is 4, so mechanical advantage is 4. You cannot take like that, right? That is one of the solved example in your concise physics also. I think the last solved example. What he has done is 2 fixed and 2 movable. Right? 4 pulleys. So if you count the pulleys and you just cram it, okay, ma'am said N is number of pulleys. No. Look at the string in this case. String goes like this. Effort is upwards here. So below the movable, above the fixed, below the movable, above the fixed, and there it gets joined here. Now you see. Now this effort, the tension will be here also. This is also supporting the load. This is one different case where effort is applied upward in block and tackle. Please remember. Now see how many string parts. 1, 2, 3. Don't miss this small one. 3, 4, 5. 5 tensions are supporting the load and the effort as. So here the effort is equal to T and load is being equated by 5 tensions. So here mechanical advantage is not 1, 2, 3, 4. It is not N. It is 5. The velocity ratio is also 5. This is a different case. Please do this before going for your board exams. Efficiency ideally 1. Percentage efficiency ideally 100%. This is a different case when effort is upwards. Please remember this is something important. And if you want to understand how tensions act, I will make another video for the tensions also. Right? That's all for the day.